Welcome back to the next episode of Blind 75. Today we are looking at the 17th problem, which is merge intervals. We are given an array of intervals where interval of I is equal to start and end. Merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So let's take a look at intervals in the example 1, 3, 2, 6, 8, 10, and 15, 18. So if you take a look at it, these two are overlapping. So we do 1 to 6, 8, 10, and 15, 18, and then return. So here in the next example, the input is 1 to 4, 4 to 5. So this is overlapping because the start time of the second interval is equal to the end of the first interval. So we will return 1 to 5. And in the constraint, we are given the intervals is at least one length. So there is no empty use case or edge case to handle. And the length can be up to 10 to the power 4. And the value of each of the entry in the array is 2. That means there is nothing so it's going to be always with start and end. We don't need to handle any other cases, and the start and the end can start from 0 and it can reach up to 10 to the power 4 all inclusive. Okay, so let's take a look at the problem and see what we can make sense out of. So I have used the same example here 1, 3, 2, 6, 8, 10, 15, 18. So this is, I just drew a line from 1 to 18 and then uh, drew all the intervals here. So 1 to 3, 2 to 6, 8 to 10, 15 to 18. So it's obvious that this part is overlapping, right? So we will merge it and make it as 1 to 6. That's what we need to do. So let's take a look at what type of interval collisions can occur. So this is an example. Say we have an interval from 1 to 3 and we have another interval from 2 to 6. So this is one type of interval where the end is greater than the previous one, and it's kind of looks like this. And the other interval could be when the second interval is interval start and end lies in between uh, the first interval. So it is fully inside here if you see. So 1 to 6 is one interval, 2 to 4 is one interval. So we have to just get rid of it and return 1 to 6. And there is another one where the second interval starts when the first interval ends, like 1 to 3 and 1 to 3 to 6. So we make it as 1 to 6. So there are three types of intervals. So how can we solve it? What we can do is we can sort the intervals by its starting time, and what we'll do is we'll iterate over this list. So here in this case, this is sorted already in the based on the start index, right? So we will start with this 1 3 in the result, and what we will do is, so we already know that it is already sorted by the start time. So we look at the next index, which is 2 and 6, right? Is 2 like whether this and this is overlapping? Yes. So what we do is we make this as the maximum of 3 and 6. So here it will becomes 6. Then we move forward. We have 8 and 10. Is 8 and 10 overlapping here? No, because 8, right? 8 is greater than the end value. So we just add 8 and 10. then we take this particular 15 and 18 and then come. So we always compare with the last interval in the result. So this is what we are going to do. Let's see how we can implement it. So we have to do the sorting first, right? Sort by start time. So intervals is equal to sorted of intervals by what we need to so we need to sort by the first value x equal to x of 7, so which is the start time. And in the result, what we will do, we start with the first index, and what we do is for I in range of 1 comma len of intervals start comma end is equal to intervals of I. So we take the first index value and start an index. If the start of the this one here, in this case this is the start. If the start is less than or equal to the end value here, right? What is the end value here? End value is result of minus 1. Minus 1 is for the last element and 1 is for the end. So we are checking whether 2 is less than or equal to 3 here. Yes, it is. That means it's overlapping, right? So what we will do is we will merge it. So what we will do is result of minus 1 comma 1. We will update this 1 as maximum. Yeah, we could say end. What is the value else here? We'll if it is not overlapping, we'll just append start comma end, then we'll return result. Okay, so let's see, let's try submitting it. Okay, so what we didn't do is we just assigned it. So what we need to do here is maximum of, I did say that but I forgot this. Okay, so maximum of end comma result of minus 1 1, whichever is the maximum value. Okay, yeah, okay, so that's it. This was easy, right? So that's it, guys. This is the end of this solution. Oh, we didn't look at the analysis, right? What is the analysis here? So this iteration is order of n. For sorting, if you think it takes say order of n log n, so it is going to be order of n log n plus order of n. So we can say it is yeah, so the runtime is kind of not dominated by order of n log n. So order of n log n to sort and order of n to iterate. So yeah, we can say it is order of n log n. What is the space complexity? So okay, so we are not using any additional since we are okay, so since we are doing it in to assign this, we can say it is order of n because we are doing sorting and storing again. So the space complexity is order of n. So if we sort intervals in place, we do not need more than the constant additional space. Although the sorting itself kind of takes order of log n space, so otherwise we must allocate linear space to store a copy of interval. So we can say it is constant here. Okay, so that's it, guys. That's the end of this video. Thank you so much for watching, and if you have any questions, please feel free to comment down below, and please like, comment, subscribe, share with your friends. I would really appreciate if you can click on the bell icon so that when I upload the next video you get notified. Also Thank you so much for watching, and see you again with another problem from line 75. See you later. Thank you. Bye bye.